Hello, this is our presentation on the M1 chip from Apple. I'm Norris.
I'm Alex.
I'm Gracia.
And I'm Kenneth.
And this will be our presentation on the M1 chip. Next slide. So to start off on product information on the Apple's M1 chip, the M1 chips were designed as a way for Apple to move away from relying on M1 chip or relying on Intel chips and moving on to their own. It integrates numerous components such as the CPU and GPU for much higher efficiency and speed, as all the components share the same memory without needing to copy data between each other. It also includes the Neural Engine, which has been in the Apple's A series, and it's 15 times faster in the M1 version than it is in the previous model. Next slide. Furthermore, from benchmark tests, the M1s are actually the highest performing amongst, or Macs with the M1 chip are the highest performing amongst all the devices. It has 4 high efficiency cores and 4 high performance cores. These performance cores are able to provide a lot of impressive performance for single-threaded tasks and high-performance multi-threaded tasks. Next slide.
So here we have an overview of the architecture design. The M1 uses ARM architecture, which is RISC-based, and RISC is a type of microprocessor architecture that optimizes instructions for more efficient operations. And a feature of RISC architecture that we're all familiar with is pipelining. The M1 isn't simply a processor, it's a system on a chip. And what this means is that the M1 combines some components of the computer that would otherwise be scattered across the motherboard into one single chip. And this benefits performance in ways that we'll cover a little later. Next slide. So here we have the components that make up the M1 chip. There is a CPU that has 8 cores, 4 of which are performance cores, and the other 4 being high efficiency cores. There is the GPU, which has 8 cores and is capable of running 25,000 threads simultaneously. There is a Neural Engine, which is meant to accelerate machine learning tasks. It has 16 cores and can handle up to 11 trillion operations per second. Also included is a Secure Enclave, which is a built-in security feature that manages Touch ID and is based on AES encryption hardware. And AES is a type of encryption where one key is used to encrypt and decrypt data through multiple rounds. The M1 also includes the SSD controller that enables users to preview large files much faster. There's also the image signal processor that outputs high quality video, improves noise reduction, and offers greater dynamic range. There's also an efficient low power encode and decode engine for better performance and extended battery life. There is a Thunderbolt controller with USB 4 support. And lastly, there is unified memory, which allows memory to be accessed faster since it's embedded into the system on the chip. And next slide. So now we have some information on performance right here. So I briefly mentioned that the CPU has 8 cores, 4 of which are high performance cores that jump into action during power intensive tasks. For less energy consuming tasks, there are other 4 high efficiency cores that are active and perform at 1/10 of the power compared to high efficiency cores. And just to get an idea of performance, with the M1, Macs offer around 15 to 17 hours of simple web browsing and 18 to 20 hours of video streaming. And I would just like to reemphasize how the structure of the M1 improves performance. And by having multiple components on the same chip, that allows data to travel at smaller distances faster and at less power. Next slide. And lastly, we have a few comparisons of the M1 versus previous Intel processors that were used in Macs. Some features in the M1, like the CPU and Secure Enclave, are now both found on this one chip, but previously models used different Intel chips for these 2 components. The Secure Enclave component on the M1 used to be called the T2 chip on Intel Macs, which is separated from the processor Intel chip. And we covered that the M1 uses ARM-based architecture, but models on the Intel used x86, which uses more power, And here we have a list of the names of some of these Intel chips, such as like the i9, i7, i5, and Intel Xeon W. Another cool comparison is that the M1's Neural Engine offers 15 times better performance than Max on Intel processors.
Okay, so our main technology that we wanted to focus on is the power efficiency of the M1. And so as mentioned before, the M1 is made up of the 8 cores, which are made up of 4 high efficiency cores that Apple actually calls the Ice Storm cores, and 4 high performance cores that are called the Firestorm cores. And Apple has stated that the 4 high efficiency cores only use up a tenth of the power of the 4 high performance cores, which is one of the crucial reasons why the M1's power efficiency is so high. And so the graph on the right shows a comparison of the performance versus power between the M1 and the latest PC laptop chips, with the x-axis being the power consumption and the y-axis being the performance. And as you can see, the performance of the M1 exceeds that of the more recent PC chips by up to 2 times the amount at the same power consumption rate. And that's because the 8 cores of the M1 work together to provide computing power for the most demanding tasks. Next slide. And so to showcase just how efficient the M1 is at saving power, we have a comparison of the M1 with a recent CPU, the i7-8700, both of which are placed inside of a Mac Mini, and the power output was recorded while the computer was in idle and while it was at full load. And so looking at the M1, its power consumption at idle was using around 7 watts, and at full load, it was using around 40 watts. And now looking at the i7, the idle power consumption rate was 20 watts, and the full load was around or more than 120 watts. And so that means that the i7 consumed around 3 times more power than the M1. And so on the graph on the right, it shows more comparisons with other Intel CPUs as well. But as you can see, none of them come close to the efficiency of the M1.
And so, summarizing everything that we learned that the M1 chip is Apple's first in-house chip for the Mac, and that its usage of RISC and ARM architecture makes it an incredibly efficient product. All this while still surpassing previous models in performance, while using 3 times less the power consumption and heat output. This means better battery life, excellent battery life. Yeah, and also you won't have to worry about it burning your lap while you're using it. And we learned that the M1 is a system on a chip, which manages to use some of the components that would have been scattered all over the motherboard. And it's right on the chip. And as how Grecia said earlier, the distance of how everything is together means that it makes it much more efficient. And in conclusion, tying these topics with what we learned throughout the semester, we can tie the M1's great performance with its use of cache. And from research, we have found that the M1 has an unusually high amount of cache. The high performance cores have around 192 kilobytes of L1 instruction cache, 128 kilobytes of L1 data cache, and they share a 12 megabyte L2 cache. And the energy efficient cores have a 128 kilobyte L1 instruction cache, 64 kilobytes of L1 data cache, and a shared 4 megabyte L2 cache. The M1 has a solid clock rate of 3.2 gigahertz, which is 3.2 billion cycles per second. And the M1's usage of RISC architecture, as we learned, makes it really great with pipelining. And yeah, that is the M1 chip. Thank you.